Today I'm having coffee with Jerome Leveneur, who is a material scientist from GNS Science.
Well, a material scientist is someone that works on trying to understand and modify the properties of materials in general. In my case, for example, is trying to understand how to control the properties of surfaces of the materials and try to get them work better for products or during industrial processes. Surfaces have different ways of interacting with fluids in general, and let's say in water. You've seen that when you drop some water on the table, for example, you can see that there is the little droplet here forming one, and they've got different sphericities, different curves into them. And so if I do a profile of those droplets here, you'll get, so this is my wood surface, and I have one of the droplets is going to be looking like this on the side, while the other one is going to be looking much more flat, much flatter. Okay. But in my world, what the difference between those two is that this one is what we say. This one here is said more hydrophilic, and this one here is the opposite. It's said more hydrophobic. For example, if you want to have a metal that doesn't want to be wetted, you don't want that the water on it spreads out too much. Ideally you'd want to be having a material where you have a droplet that is very nice and spherical around it. The advantage with that is because the surface here there's much less area in contact compared to something like here. Well, then what we do is actually we look at the surface, but we try to modify very closely here. So if I do a big zoom into this surface here, that's going to be looking something like that on the surface. If you have very well ordered small micrometer patterns on the surface, this is really how you can achieve a very high sphericity, a surface that is very hydrophobic, and we call them super hydrophobic. The only other alternative you have to control the surface otherwise is, rather than trying to create structure on the surface, you can actually change the composition of it, and you can think of the Teflon pans. They've got a coating on the surface to make them less sticky, so that's exactly the same process. In that case, they've got something called Teflon, which is a plastic called PTFE. Teflon, so they managed to stick it onto the metal surfaces, and that makes it quite unsticky. In my group at GNS Science, what we try to do instead is to get the material itself to have different properties, because the problem with coatings that they can delaminate, and you can see it with pans. They don't last so long because occasionally the adhesion between there will not be so good, and it ends up breaking and flaking off. What we're trying to do is to try to give materials these hydrophobic properties, but we're modifying them. And what I'm saying by that is, if that's, for example, if that's my surface and say it's aluminum here, what I'm trying to do is how can we change the material here so that I can change the composition there. It stays mostly aluminum, but I change the composition slightly to try and control the properties rather than having to put a layer on top. Well, imagine, say, take that curve here. Could you imagine a curve that actually doesn't end up having all the stickiness around it? It makes it a lot cleaner, a lot easier to clean. In industry, it's really about reducing the amount of time you need to clean systems. Every time you stop a machine to clean it, it's basically money thrown out of the window. So if we want to, and on the other side, if you don't do the cleaning, it's a huge problem, health problem, because you can create those little things here are where the microbes and bacteria are going to start growing, and that's what we try to avoid, all that.